we are given the circle of center 3, 2 and radius 1, point M, 4, 2, and another point N, and the angle MCN, which has a size of 30 degrees. We are asked to find the coordinates of point N. One way to find the coordinates of point N is to find the components of vector ON. Knowing that vector ON is equal to vector OC plus CN. So let's start by saying that ON, the vector ON, equal to vector OC plus CN. Let's find the component of vector OC. Now, vector OC will have component equal to 3 minus 0 and 2 minus 0. 3 and 2 are the coordinate of C, 0 and 0 are the coordinate of O, which gives 3 and 2 the components. We now need to find the components of vector Cn. We first need to find the coordinates of point N. So the coordinates of point N can be calculated as follows. Since we know the angle MCN and the circle has radius 1, so the x component within the system of axis of center C will be equal to 1 cosine 30 degrees and 1 sine 30 degrees for the y component, which gives square root 3 over 2 and 1/2. With the system of axis of center C, vector Cn will have the components equal to square root 3 over 2 minus 0, 1/2 minus 0, which gives square root 3 over 2 and 1/2. Now that we have the components of OC and Cn, we go and find the components of ON as follows by adding the components of OC and Cn. So this will be 3 plus square root 3 over 2, and the second component will be 2 plus 1/2. We added these components with these components. These are the components of OC and these are the components of Cn, which gives the final expression for the components ON is 6 plus square root 3 over 2 and 2 and 1/2. Now that we know the components of ON, the coordinates of N are given by 6 plus square root 3 over 2 for the x component and 2 and 1/2 for the y components. And these are the coordinates of point N.